Okay, so 4.9, arc length and sector area. So let's go over the definition. So first of all, we have a circle, and let's say we have a piece of pi, and we know that the radius is there and theta is there. We know that the arc is this distance of the crust of the piece of pie. And we also know that all the way around is called the circumference, and that formula is 2 pi r, which is very useful. And starting in grade 8 and 9 and 10 and 11, mostly in grade 9 and 10 when we work with circles, we knew that the arc is to the full circumference, meaning this arc bit length is to the full length all the way around. Well, what is to the arc? Well, theta is to the arc because theta is the size of the arc. And the full angle is 360 degrees. And we use this formula from grade 8 to 11 to try and figure out different lengths of the outside of a circle, or given the radius, or vice versa, given the radius, or find theta, etc. So we're going to take that formula, arc over 2 pi r equals theta, but we're going to use 2 pi. So I can times both sides by, I'm going to clean up this denominator on this side, 2 pi r. The circumference, this formula right here, substituting 2 pi for 360. So I can multiply both sides by 2 pi and they're gone. I can rewrite the formula. I'm going to substitute a for arc, and a equals, and if I times both sides by r, I get theta r. A equals theta r. Radians must be in radians. Must be in radians. If you're in degrees, convert to radians so you can use this formula, so you don't have to use this ridiculous formula from grade 8 to 11. We should start liking radians and getting to know we can use formulas like this. So what about sector area? Well, sector area, excuse me, in the diagram I'm going to highlight in big blue is the area of that piece where theta is still the angle. And I know that the area, I'm going to say capital A sub sector over area total is equal to theta over 2 pi again. And I know that the area of the sector, A sub sec, the formula for total area is pi r squared, go back to grade 8, and I can say theta over 2 pi. Now I can cross off pi, timesing both sides by pi, and then I can multiply both sides by r squared, and area of the sector is equal to theta r squared over 2. Another very useful formula, again on the formula sheets and all over the place, but I highly suggest that you learn how to start at grade 8 based on logic and then work through to get the formula, And also, if I substitute the formula in on the top, in the formula on the bottom, we actually get another formula for the area of the sector, and that one is AR over 2, also seen on your formula sheets, also very useful, but not if you have logic. Okay, a little bit more on arc length before we go. As you can see on the next page of notes, I've actually worked through a bunch of examples, substituting appropriately, doing the appropriate algebra. And then in the next page of notes, it's angular velocity. Now, I really suggest trying to stay away from formulas and taking it back to basics. If a wheel has a circumference of 10 meters, a gigantic truck wheel, and you roll it twice, how far does it go? Well, if one circumference is 10 meters and it rolls twice, well, it's going to roll 10. and then it's going to roll another 10, so it's going to roll 20 meters. So what if I said that the wheel was rolling 360 degrees per second? Well, that means that I know that I'm going to be going that 20 meters in 2 seconds. Blah, blah, blah. All sorts of different ways. Please feel free to see the notes. Maybe I'll upload that one next year.